All right, welcome back to Mr. PL's with Calculus. This is Unit 2, Day 14, and we're going to be talking about some derivatives of trigonometric functions, ones that we did not cover last time. So one of the ones that are a little bit more obscure. I'm going to show you why they are what they are, but to be honest, you just need to have these memorized in the future going forward. The first one, tangent of x, we should have already done this one before. This is actually not a new one. Had this in a prior video. So the way we did this is going to be, we're going to use the quotient rule. So we know that tangent of x is sine of x over cosine of x. And therefore, we can use low d high minus high d low over the bottom squared. And then if you simplify that, that comes this. And then this is really using your trigonometric functions, just trig identities, sorry. So this trig identity is just 1, and 1 over cosine is really just secant. So 1 over cosine squared is secant squared. So this is not something you would have to prove on the exam. You just have to know that the derivative of tangent is secant squared. All right, so the next one happens to be cotangent. Now, cotangent is the same thing as tangent, only flipped. So it's the reciprocal of it. So instead of sine over cosine, it's cosine of sine. And do the exact same process. So do low d high minus high d low over the bottom squared. So once again, using our quotient rule. And then here we simplify. From here we can factor out -1 so that we can change this to +1. -1 times 1 is -1. And 1 over sine squared is really cosecant. Negative cosecant squared of x. Now, one of the things I've noticed, and this is, since I've gone over a lot of them now, cosine, the derivative of cosine of x is negative sine of x. And then the derivative of cotangent of x is negative cosecant squared of x. One thing I do want to point out is, and I don't know how this just happened to work out the way it did, but for all the 6 trig identities, all the ones that start with C, the derivative of all the ones that start with C always end up being a negative. So cosine of x, cotangent of x, and the derivative of cosecant of x will also be a negative, as you will find out. Tangent of x, secant of x. Okay, so that's going to be the answer for that one. All of them that start with a C all end up being negative answers. And sine and cosine are basically the same thing, only one's negative. And then cotangent and tangent are basically the same thing, only one of them is going to be negative, and that happens to be the one with the C. You know, derivative of tangent is secant squared, derivative of cotangent is cosecant squared. But it's obviously got to be negative because it started with the letter C. Just one thing to keep that in mind. All right, so secant is just 1 over cosine. You should already know that's your identity. And then you can use the quotient rule again. Low d high minus high d low over the bottom squared. Simplify that down. Anything times 0 is 0. Negative times a negative is a positive. And then you end up just getting sine over cosine squared. Now, here's where it gets a little tricky. Cosine squared is really cosine times cosine. And this is the way I do it just so we can find the answer. And 1 times sine is still sine. So this is the same thing as this. I just separated it, I expanded it. I took the bottom, expanded it, I took the top, just 1 times sine, and expanded it. And that gave me this, so that I can now simplify these one at a time. 1 over cosine is secant, and sine over cosine is tangent. So yeah, derivative of secant of x is secant of x times tangent of x. And if you're a good predictor, you can probably predict d dx of cosecant, c as c of x, is, since it starts with a c, it's going to be negative. So it's going to be negative cosecant, because, you know, if secant became secant, it stayed the same. Cosecant's going to stay the same. Instead of tangent, it's going to be cotangent. And that actually is the answer, because it just follows kind of the same pattern. And there it is. You can see the reason why it comes out the way it does. But yeah, that is my way of just kind of memorizing it, is that secant cosecant is just itself times the version of tangent that matches it. And if it starts with a C, it's got to have a negative. Okay. Now, this is just the simple product rule question using secant. Derivative of secant is secant times tangent. So there's really nothing special there. For this question, it says f prime of x is, well, they gave you f of x. So the first thing I would do is find the derivative of this using constant multiple rule. Derivative of cosine is negative sine of x. So that turns out to this because a negative times a negative is a positive. And then find f prime of pi over 6 by plugging in pi over 6 in for x. Sine of 30 degrees is 1/2, and half of 5 is 2.5. 2.5 is your answer. All right, number 7. A lot of work going on in this question. This is a very common question for AP Board. They love these kind of questions where they'll give you a function, they'll give you a value of x, and it'll say either write a tangent equation or write a normal line. A normal line, remember, is a tangent line. The only difference is that it is perpendicular at that same point. So normal line, tangent line, very similar. Only difference is one's perpendicular to the other. Yeah, a lot going on here, but first thing you need in order to write an equation, you need a point and a slope to write it in a point slope form. So the first thing I always focus on is finding the point. Take pi over 3, plug it into the original function, so find f of pi over 3, that's essentially what I just said, and do that first, and then find out that that's the point. So the point ends up being pi over 3 is your x, 3 root 3 over pi is the y. Now we have the point. And that's half of the equation right there. This is going to go into the x spot. This is going to go into the y spot. And then this is going to be the slope. That's the tricky part. So to find the slope at pi over 3, first thing I need to do is find what is f prime of x, because that'll be the slope. Using quotient rule, that gave me let's see, that's a lot of work. Using quotient rule, boom, 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 got me all the way to here. So here is, it looks like that's f prime of x. F prime of x. Sorry, I don't know why I was putting a pi there. F prime of x is this. Okay, then what I need to do then is then find f prime of pi over 3 by plugging in pi over 3 in for x. And then find the actual answer, which ended up being this. And that's how we got our, oh no, that's a tangent line equation. And the normal line, so the normal line would be the exact same equation, only it's perpendicular to this, negative reciprocal of all of that. Pretty kind of crazy question here. Really just talking and walking you through the steps of find the point first. Take the x value, plug into the function, find the point first, then find the derivative of your function, and then plug in the x into that derivative to find the slope at that given point, and then you can start building that tangent line or normal line equation. All right, thanks again for watching, and I'll see you on the next one.